At the end of this video, I want you to be able to describe the modern periodic table, explain how the periodic law can be used to predict the physical and chemical properties of elements, describe how the elements belonging to a group of the periodic table are interrelated in terms of atomic number. The modern periodic table. The periodic table has undergone extensive change since Mendeleev's time. Refer to figure 5-6 on pages 130 and 131 for the full periodic table. Chemists have discovered new elements and in more recent years synthesized new ones in the laboratory. Each of the more than 40 new elements, however, can be placed in a group of other elements with similar properties. The periodic table, therefore, is an arrangement of elements in order of their atomic numbers so that elements with similar properties fall in the same column or group. The noble gases. Perhaps the most significant addition to the periodic table came with the discovery of the noble gases. In 1894, English physicist John William Strutt, also known as Lord Rayleigh, and Scottish chemist Sir William Ramsay discovered argon, a gas in the atmosphere that had previously escaped notice because of its total lack of chemical reactivity. Back in 1868, another noble gas, helium, had been discovered as a component of the sun. And based on the emission spectrum of light and studying the emission spectrum of sunlight, in 1895, Ramsay showed that helium also exists on Earth. In order to fit argon and helium into the periodic table, Ramsay proposed a new group. He placed this group between the groups now known as Group 17, the fluorine family, and Group 1, the lithium family. In 1898, Ramsay discovered two more noble gases to place in his new group: krypton, Kr, and xenon, Xe. The final noble gas, radon, Rn, was discovered in 1900 by German scientist Friedrich Ernst Dorn. The Lanthanides. The next step in the development of the periodic table was completed in the early 1900s. It was then that the puzzling chemistry of the lanthanides was finally understood. The lanthanides are the 14 elements with atomic numbers from 58, curium, to 71, lutetium. Because these elements are so similar in chemical and physical properties, the process of separating and identifying them was a tedious task that required the effort of many chemists. The actinides. Another major step in the development of the periodic table was the discovery of the actinides. The actinides are the 14 elements with atomic numbers from 90, thorium, to 103, lawrencium. The lanthanides and actinides belong in periods 6 and 7 respectively of the periodic table between the groups 3 and 4. But to save space, the lanthanides and actinides are usually set off below the main portion of the periodic table. Periodicity. Go back to this one. Periodicity, with respect to the atomic number, can be observed in any group of elements in the periodic table. Consider the noble gases in group 18. The first noble gas is helium. It has an atomic number of 2. The elements following helium in atomic number have completely different properties until the next noble gas, neon, Ne. And neon having an atomic number of 10. The remaining noble gases, in order of increasing number, are argon, number 18, krypton, number 36, xenon, number 58, and radon, number 86. These differences in atomic number between successive noble gases are shown in figure 5-4 on page 126 of your text or on the screen now. These are the atomic number differences between the elements of group 1, which are all solid silvery metals, and as you can see, the differences in atomic number between the group 1 metals follow the same pattern as the differences in atomic number between the noble gases. Starting with the first member of groups 13 through 17, a similar periodic pattern is repeated. The atomic number of each successive element is 8, 18, 18, and 32 higher than the atomic number of the element above it. In section 5-2 of this textbook, you will see that the second mystery presented by Mendeleev's periodic table, the reason for periodicity, is explained by the arrangement of the electrons around the nucleus. So at this point, I hope you can describe the modern periodic table, explain how the periodic law can be used to predict the physical and chemical properties of elements, and describe how the elements belonging to a group of the periodic table are interrelated in terms of atomic number.